In this problem, we're given the mass and spring constant and amplitude of a simple harmonic oscillator. And what we're looking for is the velocity at a specific position 10 centimeters away from the equilibrium length of the spring. So this is an energy conservation problem where the stuff we were given in the initial state allows us to find the total energy of this oscillator. And then in the final state, we can use the given position to find the spring potential energy. The only thing that's left as an unknown is the kinetic energy, which allows us to find V. So we'll start at the beginning and say E initial equals E final. And in our initial state, we have no kinetic energy because we're sitting at the maximum extension of the spring where the mass is turning around. So in that initial state, all the energy is spring potential. It's going to be 1/2 kx initial squared. And then in the final state, in our second picture here, we still have some spring potential energy. We're 10 centimeters away from the equilibrium length. So I'm going to have 1/2 kx final squared plus the kinetic energy of this thing. So 1/2 mv squared. So we can go ahead and clear the 1/2s out of here. And I think I'll go ahead and just solve this whole thing symbolically, and then we'll plug in the numbers at the end. So subtracting the kx final squared from both sides and then factoring out the k, I have k times the quantity x initial squared minus x final squared is equal to mv squared. And we'll divide both sides by m and then square root the result and turn the whole thing around to solve for v. So v is going to be k over m times the quantity x initial squared minus x final squared, all square rooted. And now we can just sub in all the numbers. So our spring constant was 10.5 newtons per meter. The mass of our oscillator was 200 grams. We need to change that to kilograms, so that's 0.2. Our initial x value was 15 centimeters or 0.15 meters, and I need to square that. And then subtract our final x value, which is 0.1 meters. And again, that has to be squared. In rounding to 3 significant digits, I get 0.810 meters per second, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.